we discussed energy stored in a capacitor in detail, and we solved some problems related to the combination of capacitors. Okay. Today, there is an important topic. How the energy stored in a capacitor affects when a dielectric is introduced between the plates, right? Between the plates of this capacitor, if a dielectric is placed, how these factors affect, and finally how this energy affects, that we are going to discuss in different cases. Well, come on. Here, this is one parallel plate capacitor. This capacitor is connected to a battery of potential V0, let us say. So the capacity of this capacitor with air as medium between the plates is C0, with air between the plates is C0. Charge let on the plates is Q0. Charge on the plates Q0. On this there is plus Q0 charge. On this there is minus Q0 charge. Charge on the capacitor is Q0. Potential difference between the plates is V0. Capacity of this capacitor is C0 with air between the plates. Electric field between the plates E0. What is the formula? V0 by D, where D is the distance between the plates. Right? We know that. And what is the energy stored in this capacitor? I am taking that energy as U0, half C0 V0 square, or half Q0 V0. There are three formulas with the different combinations. You can write half C0 V0 square, half Q0 V0, or Q0 square by 2 C0. Different one. Like. So this is the energy. These factors we know. What is the situation they are asking? When a dielectric introduced between plates, dielectric is introduced between the plates, what happens to these factors? That is the question. Well, see here, there are two cases in that. For introducing dielectric, case 1, without disconnecting the battery is the first case we'll take. Means what? This is capacitor, same capacitor. It is in connection with the battery. Potential V0, battery of potential. Now, what we are doing? Introducing a dielectric. Between the plates. of dielectric constant K, whose dielectric constant is K. This is introduced. Keeping this battery in connection, nothing is disturbed, only here one dielectric material is introduced. Then what happens to these factors? What happens to capacity, potential difference, charge and energy, so on? Let us see. We know when a dielectric slab of dielectric constant K is introduced, capacity increases by K times, that we know. So here I am taking capacity as C, Kc naught, that is known to us well. Next, what happens to potential difference? Potential difference between the plates. See, when I introduce this dielectric, immediately in the dielectrics we studied, the potential near this plate decreases. Whenever potential decreases, listen carefully. When a dielectric is introduced, potential of the plate decreases. In a principle of capacitors we studied. When potential decreases, this is ready to take some more charge. Potential, I said, it is like a level. When potential decreases, this plate is ready to take some more charge. It tries for taking the charge. Here it is in connection with the source. Battery means source can supply. There is a possibility. So it takes some more charge. Up to what extent? Till that potential comes to its original value. So whenever it is introduced, first potential decreases, then it takes the charge because cell is in connection, till that potential comes to its original value, right? So finally, what is the result we can see? Potential difference is coming to its original value, means this V, potential in this case, coming to its original value, V naught. This you have to remember. How to remember it easily, sir? Whenever it is in connection with this battery, this is parallel to this. Potential difference between these two must be equal to potential of the battery, right? So it won't change. When it is in connection, V naught, potential okay. Then what happens to charge? What I said, first potential decreases, but it is in connection with the cell, it takes some more charge, means charge is increasing, right? Charge increases. When it increases, how much? K times of its previous charge. So now Q is equal to K Q naught. Charge increases, capacity increases, remains constant potential. In theory bits we get this. Charge is increased. Then what is next one? What happens to electric field? Electric field E. We know the formula. E is equal to V by D. Here D is not changing, but V naught, D remains same. So this is V naught by D, E naught only, constant. E is also constant because V constant, D constant, where D is distance between the plates. This is constant, so it won't change. E. Next, what it is? Energy. Energy U. Any formula you can take. In this case, I am taking half QV formula I am taking. You can do it with half CV square, Q square by 2C, or half QV. I am taking this formula. half QV. Half Q, K Q naught, V naught. Half Q naught V naught is equal to initial energy U naught before introducing dielectric. Then here what happened? U K U naught. It is increased by K times. Energy increased by K times. This is the case, right? Well, here one more. Come on, note down. So final, what happened? Energy increased by K times. At what situation? A dielectric is introduced without disconnecting the battery. Without disconnecting the battery, energy increases by K times. Charge increases by K times. Potential remains constant. Potential difference. Capacity increases by K times. Well, one more. What is the additional charge? Additional charge. I said first potential decreases, so it takes some more charge till the potential comes to original value. Means some additional charge it is taking, capacitor. How much additional charge it is taking? Additional charge taken by capacitor. Additional charge comes onto the capacitor plate or taken by the capacitor delta Q. Initially, how much is the charge on Q naught? After introducing dielectric, charge becomes KQ naught. What is the additional charge taken? Q minus Q naught. KQ naught minus Q naught. Q naught common. K minus 1. This is additional charge taken. Asked in previous examples. That bit. Additional charge taken by the capacitor. On the same, what is the additional work done by the battery in giving additional charge? What is the additional work done by the battery? Additional work done by the battery. Work done by the cell or battery, you know, QV. Already I told you in the last classes. QV. Here additional work done. Delta Q. V naught means Q naught V naught into K minus 1. That is W into K minus 1. Here, what is the work done by the battery? Q naught V naught in charging. Work done by the battery in charging. If it gives a charge Q naught. See here, what is the additional work done? Q naught V naught into K minus 1. W into K minus 1. Where W is Q naught V naught. Right? Come on, note down. Next case. Next case. See here. The first case is dielectric is introduced between the plates without disconnecting the battery. By disconnecting the battery, if we introduce this dielectric slab, what happens? Just by disconnecting the battery, here I keep a switch and I keep it open. I keep it open. See. By disconnecting the battery, then what happens to these things? Capacity. Whenever a dielectric is introduced, whether battery is in connection or not, immediately its capacity increases by K times Kc naught. Okay. Once I introduce this dielectric slab, potential of this capacitor decreases. Potential difference decreases. As in the previous case, when it is in connection, it took some more charge and take it to the original level. But here, disconnected. Disconnected means there is no facility to take the charge. Means this battery is not present in connection. There is no chance to take the charge further. Means what? Initially there is a charge Q naught. Now also charge is Q naught. So there is no change in charge. Constant. You understand this? It has no chance to take the charge because battery is disconnected. There is no supply source. So charge remains same. Capacity is increased, charge remains same. I know V is equal to Q by C. So potential decreases by K times. Potential decreases by K times. Yes or no? Because I know V is equal to Q by C. Q is equal to Q naught, C is equal to Kc naught. Q naught by Kc naught. Q naught by C naught is V naught. So V naught by K. So what happened? Potential decreased. Clear? Come here. Potential is decreased. Then E is equal to V by D. V naught by D K. Because V is equal to V naught by K. So this is E naught by K. Clear? So electric field also decreases. Then what happens to energy? What happens to energy? So here things, capacity increases, potential decreases, charge remains same because there is no source in connection, electric field decreases, right? Then energy. Take the same formula, half QV, half Q is Q naught, V is V naught by K. Half Q naught V naught is U naught. Is U naught. Then U is equal to U naught by K. Energy decreases by K times. Clear? In this case, is there any additional charge taken? Is there any additional charge taken by the capacitor? No, because charge on the plates remains same, 0. Is there any additional work done by the battery? Is there any additional work done by the battery? 0, because there is no additional charge taken. These are the cases. Okay. Note point to remember is what? When cell is in connection, potential remains same. When cell is not in connection, potential difference varies. Capacity in both the cases increases. If you remember these two, you can solve. Next. Completed? Effect of distance between plates on various factors. Effect of distance between the plates on various factors of capacitor. See here. Here also two cases. Without disconnecting the battery, same thing. This is a capacitor. This is a capacitor. Distance between the plates, D. Area of each plate is A. Here, capacity C. Let it is connected to a battery. Initial cases. Here, capacity C naught, epsilon naught, A by D, epsilon naught A by D, capacity. Potential difference V naught is V naught. Electric field E naught, V naught by D, V naught by D. Charge, let Q naught. Energy, U naught, half Q naught V naught or half CV square. Q square by 2C, whatever. Any. These are initial cases. Next. Case 1. Separation or distance between plates increased without disconnecting battery. Distance between the plates increased without disconnecting the battery. Then what happens? See, same plates. Same battery. But here, what is the change we observe? Separation is increased. Initially, it is here. Now, this much separation is increased. Whenever separation increases, tell me one by one, what happened to capacity? The condition is what? Without disconnecting the battery. Battery still is in connection. What happened to capacity? Capacity. C. We know the formula. Epsilon naught A by D is the formula. Here epsilon naught A by D. Here separation is D plus X. Epsilon naught A by D plus X. This is increased. Whenever this increases, capacity decreases. So capacity decreases. Clear? Battery is still in connection. Means potential difference same V naught constant. Why? Battery is still in connection. Clear? No change of potential difference. What about charge? Q is equal to CV. Yes or no? Q is equal to C V naught. This is decreased, this is remains constant. Means decreases, Q decreases. This is next. What about electric field? Electric field E, V by D plus X. V is equal to V naught. V naught by D plus X. This is increased. Distance increased. Here it is V naught by D. Here it is V naught by D plus X. This is increased. Denominator. So total decreases. Decreases. Clear? What about energy? Energy. Any formula you can take. Half QV. How is Q? Decreased. How is V? Constant. Q, V naught. This is decrease. Energy decreases. These are the effective factors. Whenever separation between the plates increased. Come on, note down. Like you had to analyze. Just on this also we get the questions in entrance. Theoretical questions. What happens when a space is increased? Separation is increased, what happens? Separation decreased, what happens? Like this you analyze. Next. Next one. Same thing. Distance between the plates increased by disconnecting battery. Disconnecting the battery. What is the change? No battery. Battery is disconnected. What happens to these? Come on, think. Whenever distance increases, capacity C epsilon naught A by D plus X decreases. Same in both the cases. And what happened to the charge? There is no chance of decreasing or increasing the charge. Yes or no? So charge remains same. Charge remains same. Because battery is not in connection, so there is no source to take or to give out. So charge constant. When charge constant, capacity is decreased. What happened to the potential difference? We know V is Q by C, right? When C is decreased, Q remains same, it increases. Am I clear? C decreased, Q remains same. This is Q naught by C. Q naught remains same. This is decreased. So potential difference increases. Come to electric field. This electric field. E. Electric field. Sigma by epsilon naught Q by A epsilon naught, can I write? Q, how it is? Constant. Q constant. A, no change here. Epsilon naught, no medium change. So this is Q naught by A epsilon naught constant. It won't change. Right? Then finally, what is energy? What is energy? Energy U half QV. Q remains constant, V is increased. So energy increases. Yes or no? Here Q constant but V increased. So energy also increases. If you want, you can substitute values and you can take. You can find this energy with three formulas. Any one of that you can use. One I used here, half CV square, Q square by 2C. Anything use it and you find it. Energy increases. Right? This is the effect of increase of distance between the plates. In the same way, you can think of decrease the distance also. Okay? But whenever question comes in the exam, you have to analyze in this manner. Come on, note down. Yes. So next topic is when two capacitors are connected, how the charge distribution takes place and how the energy distribution takes place. We just see. Okay. In the next class. Okay.